we set out to discover how a computer works. And so far we've covered the electrical fundamentals we'll need to understand how they work. Today what we want to look at is what pieces go into a computer. What pieces do we need to understand in order to know how a computer works? A computer is formed of a number of discrete components, each part with a very specific job to do, and well-defined interfaces so that they can communicate. Today we're going to look at the categories of these parts so that we can understand the kind of jobs that need to be done in a computer and what parts actually do them. First category of devices are input-output devices, or I/O devices. Think your mouse, your screen, network cards, network cables, hard drives, disk drives, SSDs, USBs, anything which inputs or outputs data from your computer. We won't be looking too much at input-output devices in this series because they're peripherals. They often work very differently, but the functions that they perform are somewhat straightforward. If you would like to know how a particular I/O device does work, then let me know in the comments and we can certainly do a separate video or set of videos on particular input-output devices. Next there is memory, or RAM. While you're using your computer, everything that you're doing is being stored in memory. All of your programs and data are stored in memory while you're using them. But memory is volatile. As soon as your computer powers off, as soon as you unplug it from the wall, everything in memory is lost. This is why we use hard drives or SSDs to store our data, to persist it between sessions, and then load it back into memory when we need to use it next time. Unlike hard drives and disk drives though, memory is randomly accessed. RAM stands for random access memory, and it means that we can access our data from any point at any time in any order. Finally, there's the processor, or processors. The CPU is the central processing unit, and this is where most of the magic happens. All of the logic and computation that happen inside your computer happen inside the CPU. Now your CPU can have multiple cores. This means multiple discrete components, each able to execute instructions by itself independently. This enables your computer to execute a number of instructions, run a number of programs at the same time in parallel. Now a CPU is not the only kind of processor. The CPU is a generalist. It is able to do all manner of logic and mathematics, but it's not good at specialized computations. For example, graphics. This is why GPUs are now popular for games, amongst other things. Because the GPU, the graphics processing unit, has very special circuitry that's able to carry out computation and logic for very specific operations. Inside the CPU there are a number of components which together form the operational powerhouse of the computer. Registers are very small blocks of memory, only a few bytes in size. And these store data which is work in progress, which is currently being operated on. Aside from that, there are also specific registers which have very particular purposes. For example, there is an instruction register inside each core of your CPU, which keeps track of the current instruction being executed. Cache is a medium-sized block of memory, a few kilobytes or megabytes in size, which the CPU uses to store data or program data that it is using now or imminently. Cache is much faster to access than memory, So having data stored here, which we're going to be using frequently, is very helpful. If a CPU knows that it's going to use a particular block of data, it will load it from memory into cache, operate on it, and then when it's done, save it back into main memory. The idea of caching is very popular at all levels of computer science. Making data that we're going to be using frequently and imminently available very quickly is popular and a good idea for a number of reasons. And caching is used everywhere. This certainly won't be the last time that we visit the idea of caching. Next is the ALU, or the Arithmetic Logic Unit. This is where all mathematical operations are performed inside the computer, and all logical operations too. In the very next video, we'll be taking a look at how part of the Arithmetic Logic Unit could be built. A bus is literally a set of wires down which we can send data and instructions so that different parts of the CPU and different parts of the computer can communicate. There's not much more to be said on buses than that, although in the coming videos we will see a number of examples of using buses in order to communicate between pieces. Side note, USB stands for Universal Serial Bus and defines one particular kind of bus where data is sent in serial or in sequence into a computer as a method of I/O. The control unit is one of the most important pieces inside the CPU. It is literally the brain of the CPU. It is responsible for interpreting all of the instructions that you give it through programs, through code which is compiled down to machine code, and then turning on the various other components inside the CPU so that they can operate according to those instructions. That it tells different components to read or to write from the bus, to operate on data, and so on. It is literally the brain of the CPU, and we'll be taking a much closer look at this in a few videos' time. Finally, there is the clock. If the control unit dictates what the CPU does, the clock dictates when it does it. The clock is like a heartbeat, pulsing regularly, telling the CPU when to execute each micro instruction. You've probably heard of processors referred to in terms of frequencies. For example, this processor is a 2.4 gigahertz processor. That frequency is referring to the CPU clock. 2.4 gigahertz, for example, means that the clock pulses more than 2 billion times per second. So that's 2 billion and more instructions or micro instructions per second, which is just unimaginably fast. In the coming videos, we'll be taking a look at each of these components in the CPU and in the computer, taking a look at how they work together in order to do everything that we know a computer can and does do. If you have any questions or comments, make sure to leave them in the comments below. This is video 4 in this series on how computers actually work, and there's plenty more to come, so make sure to click subscribe and turn on notifications down below so that you don't miss a video. This is 54M, and I'll see you soon.